A dam's crucial canal, in poor condition and threatening water overflow, needs urgent repair. The team at MK Project is taking on the task. Japan's history of calamitous monsoon floods presents a challenge that demands exceptional rigor. They will employ a game-changing construction technique, fabric formwork, transforming a months-long task into a 2-day operation. The process begins by laying the fabric sheet along the channel. This flexible material envelops the base and sides, creating the mold for the concrete waterway. Unlike traditional methods, which require extensive excavation, complex wooden forms, and weeks of curing, this innovative approach uses fabric as the mold, significantly reducing construction time and costs while delivering a strong, durable result. A carefully designed concrete mix will be pumped directly into the fabric formwork through a hose. The concrete mix is crucial. It must be fluid enough to flow into every crevice of the fabric mold, yet strong enough for structural integrity. Once the hose is connected to the injection port, the concrete begins to flow. As the mixture fills the mold, the fabric inflates, shaping the channel's contours. Throughout the injection, technicians monitor the pressure and flow rate, making real-time adjustments to ensure consistent density. The workers utilize state-of-the-art jackets with built-in battery-powered fans to combat the heat. The fabric's permeability allows excess water from the mix to escape, accelerating the curing process compared to traditional methods. Soon, the concrete hardens into a robust structure, precisely conforming to the mold. The fabric, made of synthetic fibers like polyester and nylon, is pre-shaped with carefully designed folds and seams. These folds and seams serve two purposes. They reinforce the structure and guide the flow of concrete during injection, ensuring even distribution. The process is staged. First, concrete is injected to form the channel's base and one side wall. Once these sections have partially hardened, a draw thread, previously sealing the adjacent section, is pulled, allowing the final section to be filled. This thread creates a temporary barrier to control the flow of concrete during the initial pour. As the initial sections set, the team reviews the progress and discusses this innovative approach.
Would you like to build formwork and pour concrete the traditional way?
The original design here was built that way, but that would be too much work. The work here wasn't done well, that's why we need to repair it.
The civil engineering industry has a shortage of human resources. This is better than building something so time-consuming, and you need less manpower.
Build the formwork, pour the mixed concrete, hit the bottom wall. It's a lot of things.
Even if we dig a channel, this amount of digging is not enough. Because there is the need to assemble the rear frame, we would need to dig extra deep. Once the retaining wall is completed, it takes a lot of time to fill the back.
The number of processes needed is less than?
Yes, it takes less time, and ultimately the whole process is shorter.
Also, the mold is bumpy, which will slow down the water flow. It would flow faster if we did it the traditional way. It's all good things.
The team is pleased with the efficient progress, and the project remains on track for completion within 2 days. The fabric's permeability is key to superior concrete quality. By allowing excess water to escape, it lowers the water-cement ratio, crucial for long-term concrete durability and minimizing cracking. To stabilize the fabric formwork against the concrete's weight, tension ropes are attached to the fabric and anchored to sturdy support stakes driven into the ground, then tensioned using lever blocks. This prevents shifting or collapse during injection. This process is repeated along the channel, ensuring each section is filled, stabilized, and shaped precisely. Ongoing research is further advancing fabric formwork. Integrating sensors into the fabric allows real-time monitoring of curing and stress, ensuring consistent quality. As the second day begins, the workers maintain their focused pace. This innovation is a game changer for channel repairs and flood control, with potential applications in retaining walls, foundations, landscaping, and even architectural designs. It is gaining traction in Japan, Canada, and the United States, showcasing its potential for widespread adoption. The goal of a robust channel, capable of withstanding future water flows, is within reach, and work continues at full speed, with the project past the halfway mark. Achieving this with traditional methods would have taken weeks. Realizing the full potential of fabric formwork requires training. Crews are mastering this technique, leading to safer jobs, faster construction, and more successful projects. These skills mean local workers rely less on outside help and gain better job opportunities that strengthen their role within the community. As each formwork sheet is set in place and filled, quality checks intensify. Workers use their feet to apply gentle pressure, ensuring the surface stays smooth. The internal pressure remains even, and air pockets don't form inside. Beyond the threat to human life, floods cause immense damage to property and infrastructure. Investing in technologies like this is a sound investment, potentially saving billions in damage. In earthquake-prone regions like Japan, seismic resilience is also paramount. The inherent flexibility of fabric formwork, combined with the strength of the reinforced concrete, creates structures that are better able to withstand seismic activity. Once the concrete has sufficiently hardened, the final shape is refined. Technicians seam the edges of the fabric for a precise fit. The completed structure is then inspected to ensure it meets all required specifications. The project is nearing completion, with only one side wall left to construct within the remaining 2-day time frame. Once this final section is in place, the structure will be fully enclosed and ready for its finishing touches. Once the fabric is fully filled, the last area to receive concrete is a small extension of material, sometimes called a filling point, that prevents any overflow. After it's packed, the workers tie it off, leaving a modest protrusion behind. As the concrete sets and the channel takes on its final form, the outer surface is thoroughly flushed to remove any lingering debris. The outcome is a clean, resilient structure that signifies the project's successful completion. Thanks to this technique and the skilled workers, a robust waterway has been completed. This speed and quality were once considered impossible. Such developments are transforming construction, making projects faster, stronger, safer, and more efficient. As technology evolves, the future of groundbreaking techniques remains full of possibilities.